Welcome everyone, today we'll talk about slices in Rust. Slices are references to a contiguous sequence of elements in a collection. And this is the last lesson about ownership, references, and borrowing. Slices are basically views to the original collection, and this is what makes them really memory efficient. They don't store any data by themselves. It's just to view some data. And so slices, where are slices used? To check a part and have a part of a collection or a whole collection, or to iterate on a specific collection. The syntax is this one, is and t in square brackets, where t is the type of elements and is the reference to the collection. Let's see a slice of an array of characters. We saw these types in the data types lesson, so I'll go faster here. Let's define this array of characters. Arrays in Rust as a fixed size, so I need to define here also the size of this array that can't change. In this case we have A, B, C, D, E, and now we define a slice. We define a variable called slice and char equal and r 1.3. Let's try to print this cargo run -q, and we have B, C. We start from 0, so A index 0, then we have B on 1, C on 2, D on 3, and E on 4. 1.3, it means that we will print B, which is on index 1, the second element, then C, but we will not print D. So this does mean that if we have 3 as an index, the last index, this will not be included, this will be excluded. Let's see a second example. A slice of a vector of integers. Vectors are basically resizable arrays. They are dynamic arrays in Rust. Let vec of type i32, 10, 20, 30, 40, 50. Create a slice here. Okay, so this should be clear. Third example, slices for strings. Let s string from hello world, and then we define two variables. One is hello, and we get the string with the range 0.5, then word string 6.11, and then we print hello and word. Cargo run -q, we have hello and word here. Now let's talk about ranges shortcut for slices. Let s equal string from Francesco. Shortcut for initial index. If we have a slice 0.3 and we can print it, we can have this shortcut. Let slice and s.3, and then we can print it. Cargo run -q, and we see we have the same output. Instead of having 0.3, we can just have .3. Shortcut for final index, we can get the length of the string, and then we can have a slice that starts from 4 and s square brackets 4.len. We can print it, or we can have this one, line 15, as an range 4 ... with the print. And we have Cesco as output here. We can also have a shortcut both for the initial and final index. Let slice at s 0.len. We can print this whole slice, or we can use this syntax. I really like this one. And s square brackets ... close the square brackets. And then we can print it. And we have Fra, Cesco, Cesco, and Francesco, Francesco. Let's see an exercise. Get the first word of a string. And we will start implementing this exercise without slices. So we have this function. This function is called the first word. It gets in input a reference to a string, and in output we have a usize, which is basically an unsigned integer. We convert the string to bytes here because we want to iterate through the bytes, and then we want to return, in this case, just the index of the first space. This B single quote space single quote is the meaning of the space in bytes. And here we can return this I index. In case we have no space, for example, we have a single word, we can return the length of the string, or basically the index of the last character of this single word. So let s equal string from hello world. We define a string hello space word. Let me define another variable called word. I want to print the s string and then the word ds is, and then you can print the first word like this: cargo run -q, and we have the s is hello world, the whole string. The first word is the index of the word, but is okay, is 5. If I change hello world to hell world, like this, we have s is hell world, the first word is 4. If I put here hello world without any space, the first word is equal to 10. There is a problem here. If I do anything with this string, I modify it. For example, I can call this .clear method on the string. What would happen if then I print the value again? Of course, this variable has to be mutable, otherwise we'll have an error. Cargo run -q, the s is hello world, the first word is 10. And then after clearing the string, the first word is still 10. We can fix it using slices. Let me clean the things a bit here. Let's leave the space, let's remove the mutable variables. This is the implementation with slices. On line 10, on the signature of the function, as a return type, instead of returning a number, which is basically the index of the last character of the first word, let's try to return the actual word. And string, on line 16, instead of returning I, we can return this and s 0.i. We are returning all the characters starting from 0, the first letter, until the character before the space. And if we have no space, what will be the output here? We return the whole string with this and s dot dot. Let's try. And in this case, it works. The s is equal hello world. The first word is hello. If we change hello world with hell, like this, we have the first word is hell. So now we are getting the actual word. If now, let's put this back to mutable, let's put it back to hello world, and here we clear the string, and we try to print s is equal, and the first word is equal again after, we'll get an error. And this is amazing. Cannot borrow s as mutable because it's also borrowed as immutable. Why? Because these slices are immutable references. And this is great to avoid confusion and to avoid mistakes, because after we use this slice as a mutable reference, we can't call the s.clear method. And this is how we can solve many problems and add hatches at compile time. We are almost done, but I want to try something else. Let's remove the clear part. Let's remove this mutable, because here we used strings, the string type with capital S, the one that goes in the heap. Can we use string literals? Let's define a variable called s2 equal to second word. We define a variable called word2 equal to first word, the function, with a reference to this s2 variable. Then we print s2 equal to, the first word of s2 is equal to cargo run -q. We have a mismatched type. Here in the signature of the function on line 17, instead of end string, I should put end str. Cargo run -q. It worked. Why, if we had and string with capital S, it didn't work for the string literal, but if we add and str, it works for the string on line 4 and 5. If you have and str as a type in the arguments of a function and you pass a reference to a string with capital S, Rust will do what is called the defer trait, and basically it will coerce the reference to this at string with capital S to end str, and this will work. It's usually a good practice, if you're not sure, to use end str as a type in the arguments of a function instead of using end string capital S, because otherwise you can't use the string literals. What if I remove on line 11 this reference? Cargo run -q and it works. So we don't need to pass the reference to a string literal, and the reason is this one. String literals are slices. Boom. Plot twist. String literals are slices of strings already. They already have this reference, so we could pass the reference of a reference, but honestly is not necessary. And this is the end of this lesson, and I hope this was clear and we learned something else about string type with capital S, string literals, which are slides and are basically buried in the binary of the program when we compile it. This is the end of the ownership chapter and lessons. Of course, we will always keep having ownership references. I'm talking about lessons about specific topics.